In this session, we are going to solve a few questions based on quadratic equations. These are word problems based on age as well as geometry. So let's take a look at the first question. 1 year ago, a man was 8 times as old as his son. So this is the first condition given to us, that 1 year ago, the man was 8 times as old as his son. Now his age is equal to square of the son's age, right? So right now his age is square of the son's age. So let us go ahead and make a nice table for this particular problem. So in this particular question, there are two people. One is man and then there is his son is there, right? So it's given that 1 year ago, it's given that man was 8 times as old as his son. So if his son's age was x, then his father's age was 8 times the son's age, that is 8x. Now what is his age? What would be their ages today? So if 1 year ago my age was 29, then my age right now is 30. Therefore, if 1 year ago man's age was 8x, today his age is going to be 8x plus 1. Similarly, if the son was x years old 1 year ago, then his present age is going to be x plus 1. So now let's see what is the condition that is given. Now his age is equal to the square of his son's age. That means the man's age today, that is 8x plus 1, is the square of the son's age. That is, it is x plus 1 the whole square. This is the condition right now. So now what I'm going to do is I'm going to open up the brackets. So I get 8x plus 1 is equal to a plus b the whole square is a square plus 2ab plus b square. The 1 cancels and therefore I get 0 equals x square plus 2x minus 8x, which means x square minus 6x is equal to 0. And therefore factorizing, I can say x bracket x minus 6 is equal to 0. So this implies either x is equal to 0 or x is equal to 6. And the son cannot be 0 years old, which means that the son was 6 years old 1 year earlier, right? So the son's age 1 year ago was 6 years and the father was 8 times 6, that is the father was 48 years old. Now what is the question that they have asked? Find their present age. So we have to find their age today. So today the father's age is going to be 1 year ago the father was 48 years old. So today the father is going to be 49 years old. The son was 6 years old 1 year ago and now the son is 7 years old. Therefore, I can say that their present age is therefore, their present ages are 49 years and 7 years respectively, right? The father is 49 years old and the son is 7 years old. So this is how I can create the table. Again, let us quickly take a recap of how we created the table. We first saw that 1 year ago the man was 8 times as old as his son. So I took the son's age as x. So father was 8 times the son's age, that is the father was 8x. Now 1 year later, that is today, so 1 year ago the age was 8x, so today the age would be 8x plus 1 and x plus 1. And then the condition was, right now his age is, the father's age is square of the son's age. So then 8x plus 1 was x plus 1b whole square. So after I made this equation, then I just solved for x, and mind you, here x was the age of the sun 1 year ago, right? That is why you have to be really careful. Don't write the answer as 0 or 6, or don't even write the answer as 6, because 6 is the age of the sun 1 year ago, and they are asking us the present age. So we have to find these ages, that is 8x plus 1 and x plus 1. So this is how we go about this particular problem. Pausing for a minute before I move on to the next one. Moving on to the next question. So let's take a look at this question. The product of Ramu's age 5 years ago and his age 9 years later is 15, right? We have to find his present age. So let's see how to find this particular present age. Again, let's assign a variable for his present age. So I can say that let the present age be x years, right? Now if the present age is x years, then the age 5 years ago, so Ramu's age 5 years ago is therefore going to be x minus 5. And similarly, Ramu's age 9 years later is going to be x plus 9, right? So again, the present age is x. So if I were to draw a timeline, right, the present age is x. Right now, the age of Ramu is x. This is x today. And 5 years ago, so 5 years ago, his age would be x minus 5, because you're going back in time 5 years ago. So the age is x minus 5. And 9 years later, again 9 years later is with respect to today. So 9 years later, the age is going to be x plus 9. And it is given that the product of their age, so the product of these two ages, this age and this age, is going to be 15, right? So let us now solve this particular question. So it means that x minus 5, the age 5 years ago, multiplied by the age 9 years later, this product is going to be 15, right? This is according to the given condition. And now I can simply open up the bracket. So x into x becomes x square, and x into 9 becomes 9x, negative 5x, negative 45 is equal to 15. And therefore, on simplification, I get x square plus 4x minus 60 is equal to 0. So this is the quadratic equation that I should be solving. The product is minus 60. And the sum is plus 4. That means the numbers are definitely 10 and 6. 10 6 are 60. The sum is positive 4, so it's positive 10 and negative 6. So I can solve this as x square negative 6x plus 10x negative 60 is equal to 0, which means x into x minus 6 plus 10 times x minus 6 is equal to 0. and therefore x minus 6 bracket x plus 10 is equal to 0. Now product of two numbers is 0, means either one of them has to be 0. So therefore x is either positive 6 or x is negative 10. Now x is the age of the person, so it cannot be negative. So we will have to explicitly mention it, that since x equal to negative 10 is not possible, as age cannot be negative, and that is why we accept only x equal to 6. That means his present age is 6 years. So the answer is Ramu's present age is 6 years. A quick check. Today if he is 6 years old, then 5 years ago he was 1 year old, and 9 years later he is going to be 15 years old, and 1 into 15 gives you a 15. So therefore our answer is perfectly fine. Again pausing for a minute before I move on to the next question. Moving on to the next question. Let us take a look at the following question. The sum of the ages of father and son is 45 years. So it's given that the addition of their two ages is 45. 5 years ago, the product of their ages in years was 124. Okay. So again, let us make a nice table for this particular problem. There are two people in this particular story, the father and the son. So let's quickly make the entries for their ages, right? So let's consider father and son. So today, the sum of their ages is 45. So I would say let the father be x. And if the father is x years old, then the son is going to be, so son's age will therefore be 45 minus x. So why 45 minus x? Because the sum of their ages is 45, right? So if the father is x, then son is going to be the remaining part of 45. So x and 45 minus x. Now it's given that 5 years ago. So if today their age is x and 45 minus x, let us quickly find what is their age 5 years ago. So 5 years ago, the father's age would be x minus 5, right? X reduced by 5. And son's age would be 45 minus x minus 5. So 45 minus x minus 5 is therefore going to be 40 minus x, right? So the son's age 5 years ago is going to be 40 minus x. Let us quickly add that in that particular cell. So this is going to be 40 minus x. Now it's given that 5 years ago, the product of their age was 124. That is father's age 5 years ago. Multiplied by son's age 5 years ago. The product was 124. Now let us ignore math for the time being and let us use some common sense. Of course, math is common sense. So instead of going ahead and directly mathematically building this particular equation, can you just spend a minute in logically thinking about this question? And then of course we will solve it mathematically, using an equation as well. But using mathematical logic, can you come up with the answer on your own? I will give you a minute to do that. So my common sense tells me that if the product is 124, then what are the possible options that I have? So 124, one option is 124 ones are, that is the father is 124 years old and the son is 1 year old. That seems to be a little, it seems to be a very difficult possibility. The other option that I have is 62 twos are, again 62 and 2, the father being 60 and son being 2. Again, that is a bleak possibility, and moreover, the sum of their ages will not be 45 in that case, right? Because 5 years ago, this is the age 5 years ago, so the age today is 67 and 7, and that won't add up to 45. So this also looks difficult. One possibility is therefore 31 fours are, and 31 fours are is quite a decent possibility, because 31 into 4 is 124, and this is the age 5 years ago, so today their ages would be 36 and 9, and wow, 36 plus 9 is also 45. Therefore, the right answer to this question is going to be 36 and 9. So as you will notice with this example, mathematics is not just about framing equations and solving equations. It is lot of common sense also involved in solving a particular question, right? So I hope that you understood what I was trying to explain over here. Let me now use quadratic equations to solve this question. So father's age 5 years ago was x minus 5, and son's age 5 years ago was 40 minus x. So this product was equal to 124, right? And now I can open up the bracket. So x into 40 is 40x, and x into minus x is minus x square. Minus 5 into 40 is minus 200, and minus 5 into minus x is plus 5x is equal to 124. And therefore this becomes minus x square. 40x plus 5x is 45x, and minus 200 is equal to 124. Let us shift the 124 also to the left hand side. So I get minus x square plus 45x minus 324 is equal to 0, and multiplying the whole equation by minus 1, I get x square minus 45x plus 324 is equal to 0. So this is now going to be solved for the age of father. If you notice, x is the age of father. So solving this, I will get the age of father. Now we need to find two numbers whose product is 324 and sum is minus 45. So let's try to find that. So 324, let's factorize. It is 162 twos are. It is 81 fours are, still not working. Let's divide this by say 3. Divide this by 3, you get 27, and multiply this by 3, you get 12. No, this is also not working. Let us now divide, split 27 into 2 factors, that is 9 threes are, and let us split 12 as 4 threes are. Let us see if some combination of this helps. I notice that 9 fours are is 36. And 3 threes are is 9, so 36 and 9 is one more possibility. So I get x square minus 36x minus 9x plus 324 is equal to 0. So factorizing this, I get x minus 36 into x minus 9 is equal to 0, which means x is either 36 or x equals 9. Now mathematically x could be any of these two, but if I use the right approach, then father's age cannot be 9 years, right? So that is not possible. Hence, you should note down that discarding father's age as 9, discarding father's age as 9 years, we are now left with only one option, which is x equals 36. Therefore, father's present age is 36 years old and son's present age is 45 minus 36, that is 9 years old. And if you notice, that exactly matches our answer that we got without framing the equation. So, I hope you understood this particular question. Let me again pause for a couple of minutes and then we will continue. Moving on to the next question. So let's take a look at the following question. 7 years ago, Varun's age was 5 times the square of Swati's age. So there are two people in this story, Varun and Swati. 3 years hence, Swati's age will be 2/5 of Varun's age. Find their present ages. So we need to build the table over here. So let's start building the table. Now, when you build the table, the best starting point is the point where you at least know some relation between their ages, and it looks like the good point or a very favorable point where I know the relation between their ages is when it is 7 years ago, right? So I will go ahead and I will start from that point. So let me create the column for these two people. So I have Varun here and I have Swati here, right? Now it's given that 7 years ago. So let's see what is the story 7 years ago. 7 years ago, Varun's age was 5 times the square of Swati's age. So the right place where you can insert the variable is where the relation is known. Right now it is 5 times the square of Swati's age. So I would take Swati's age as x. So let Swati's age 7 years ago be x years, right? And it is given that Varun was 5 times the square of Swati's age. That means Varun's age was 5 times the square of Swati's age. So Varun's age was therefore 5x square. Now this is the story 7 years ago. Let us see what will happen today. Now if Swati's age was x years old 7 years ago, then her age today is going to be x plus 7, right? The age will increase by 7. And if Varun's age was 5x square 7 years ago, then his age today is going to be 5x square plus 7, right? Both their ages will increase by 7 years. Now 3 years hence, so the commonly asked question is, when is it considered, when are these 3 years counted from? So 3 years hence, everything is always counted with respect to today's age, right? So when they say 3 years hence, it means 3 years from today. Okay. So if Varun's age is 5x square plus 7 today, then 3 years later his age will be given by 5x square plus 7 plus 3, and this age will be x plus 7 plus 3. So therefore Varun's age is 5x square plus 10 and Swati's age is therefore x plus 10. Now let us build the condition. 3 years hence, Swati's age will be 2/5 of Varun's age. So let's write it. Swati's age will be 2/5 of Varun's age, right? Therefore, I can say that Swati's age after 3 years is going to be x plus 10. This will be, so that equals 2/5, that is 2 by 5 of Varun's present age, which is 5x square, Varun's age 3 years hence, that is 5x square plus 10. So let me just pause for a minute so that you can take a look at the table as well as how we frame the equation. Solving this equation is now not a very big challenge. It's very easy to solve this equation. But the main part is understanding how we framed the different entries of this table and how did we frame the equation. That is the real challenge. So let me pause for a minute. So now let us solve these equations. This 5 is in division. On the other side it goes to multiplication. So this becomes 5 times x plus 10 is equal to 2 times 5x square plus 10. So expanding the brackets, I get 5x plus 50 is equal to 10x square plus 20. Shifting all the terms to one side, let's shift everything to the right hand side. So it becomes 0 equals 10x square minus 5x minus 30 is equal to 0. And therefore dividing everything by 5, everything is divisible by 5. Sorry, I shouldn't have written the equal to 0 again. So dividing everything by 5, therefore I get 2x square minus x minus 6 is equal to 0. So this is the quadratic equation that I should be solving. And therefore if I factorize this particular quadratic equation, I will get 2x and x and negative 2 and a positive 3 is equal to 0. So this implies x is either negative 3 by 2 or x is equal to positive 2. Now of course the age cannot be negative, so we discard. Now you have to explicitly mention this that I am eliminating the negative value for x because x represents the age of a person. And therefore the value of x is equal to 2 and hence Swati's age 7 years ago. So what was x? X was basically Swati's age 7 years ago. So we need to find their present age. So let us quickly substitute x as 2. So Swati's present age is going to be 2 plus 7. So 2 plus 7 is 9 years and this is going to be 5 into 2 square. So 2 square is 4, 5s are 20 and 20 plus 7 is 27, right? So this is their age, this is their present age. Swati is 9 years old and Varun is 27 years old. Let us quickly check if they satisfy the given conditions. That would be a good check to have for checking your answers. So 7 years ago, Swati would be 2 years and Varun would be 20. So square of Swati's age is 4 and 5 times that square is 20. So that condition matches very well. And 3 years later, Varun is going to be 30 years old and Swati is going to be 9 plus 3, that's 12 years old, and 12 is indeed 2/5 of 30. So even that particular condition matches, and hence our answer is perfect. So again, pausing for a minute before I move on to the next question. Moving on to the next question. So let us now solve some questions based on geometry. This is the first one. The hypotenuse of a grassy land in the shape of a right triangle is 1 meter more than twice the shortest side. So let's quickly draw a right angle triangle. Let's consider that the vertical side is the shortest side. Okay. So let's mark the right angle triangle. I have A, B and C, and angle B is equal to 90 degrees. Let us write what is given. The hypotenuse is 1 meter more than twice the shortest side, right? Twice the shortest side. And the third side is 7 meters more than the shortest side. So over here you will notice that hypotenuse and the third side are given with respect to the shortest side. So I am inclined to take my shortest side as x, because that is a good reference to have, right? The other two sides are being expressed in terms of the shortest side. That is why taking the shortest side as x is actually a very good idea here. Now let's frame the expressions for the other sides. The third side is 7 meters more than the shortest side. That is, the third side is going to be x plus 7. And the hypotenuse, that is AC over here, is 1 more than twice the shortest side. So the hypotenuse is going to be 1 plus 2x. So here I can say that let the shortest side be x. Let the shortest side be x. And therefore the third side is therefore x plus 7, while the hypotenuse is going to be 1 plus 2x. And now we need to have an equation which can be framed. What is the relation between these three sides? Now, because this is a right angle triangle, I can definitely apply Pythagoras theorem. So I can say, applying Pythagoras theorem, I can say that 1 plus 2x the whole square is equal to x square plus x plus 7 the whole square, right? Hypotenuse square is the sum of squares of the other two sides. And now opening up the brackets, I can easily get my quadratic equation. So 1 plus a square plus 2ab plus b square is therefore equal to x square plus 14x plus 49. And therefore what I get is 1 plus 4x plus 4x square is therefore equal to 2x square plus 14x plus 49. And grouping all the terms on one side, I get 2x square negative 10x negative 48 is therefore equal to 0. Dividing throughout by 2, I get x square minus 5x minus 24 is equal to 0. So this is a quadratic equation. Of course, I can factorize it as x minus 8 into x plus 3 is equal to 0, which means x is either positive 8 or negative 3. Now again, discarding the negative value, you get x equal to 8. And they are asking me to find the sides of the grassy land, which means I have to find all the three sides. So x is 8, which means the sides are 8. The sides of the grassy land, are therefore x is 8 meters. Then x plus 7, so 8 plus 7 is 15 meters. And 1 plus 2x, so 1 plus 2 times 8 is 17 meters. So these are the three sides of the grassy line. So this is how we go about this particular question. Let me again pause for a minute and then we move on. Moving on to the next question. So let's take a look at the following question. Vikram wishes to fit 3 rods together in the shape of a right triangle. Okay, so let's quickly draw a right triangle. The hypotenuse is 2 centimeters longer than the base. The hypotenuse is 2 centimeters longer than the base and 4 centimeters longer than the altitude. Okay. So over here you will notice that the hypotenuse is a good reference point to pick because the other two sides have been compared with respect to the hypotenuse. So let's quickly label the vertices. I have triangle ABC where angle B is equal to 90. These are the three rods. AB, BC and AC are the three rods. The hypotenuse is 2 centimeters longer than the base. So hypotenuse is 2 centimeters longer than the base, which means the base is 2 centimeters shorter than the hypotenuse, right? And therefore, if I consider my hypotenuse as h, then the base is 2 centimeters shorter than the hypotenuse, which means it is h minus 2. It is also given that the hypotenuse is 4 centimeters longer than the altitude, which means that the altitude is 4 centimeters shorter than the hypotenuse, right? And therefore, if the hypotenuse is h, the shorter length is h, or the altitude is now h minus 4, right? So now I can use the Pythagoras theorem to frame the equation. But let me again pause for a minute so that you can take a look at the statements and try to see what we have done. Because now building the Pythagorean equation is really simple and solving the quadratic equation is also going to be easy. But this is the main part. How did we frame the expressions? So let me pause for a minute. So let us build the equation now. So we get h square is equal to h minus 4 the whole square plus h minus 2 the whole square. Of course, I can expand using a minus b the whole square. That's a square minus 2ab plus b square plus a square minus 2ab plus b square. H square cancels, and therefore the equation that I get is h square minus 12h plus 20 is equal to 0. So therefore I get h minus 10 multiplied by h minus 2 is equal to 0, which means h is equal to 10 or h is equal to 2, right? And let's see which of these options is really possible. Now if h is equal to 10, this length will become 10 centimeters. The hypotenuse becomes 10 centimeters. The length AB becomes 10 minus 4, that is 6 centimeters. And the base becomes 10 minus 2, that is 8 centimeters. So the lengths of the rods are therefore 8, 6 and 10 centimeters. The length of the rods, or the length of the rods is 6 centimeter, 8 centimeter and 10 centimeter. And if I take h equals 2, then this base becomes 0 and that is not a valid option. So we have to discard h equal to 2 as a valid option. So though the quadratic equation gave you two roots, only one of them is valid over here, and hence the lengths are 6, 8 and 10. So let me pause for a minute and I will continue to my next question. Moving on to the next question. Let us consider the following question. The hypotenuse of a right angle triangle is 6 meters more than twice the shortest side. So let us consider the following right angle triangle. So I have ABC, angle B is 90. Now let's see what are the conditions. So hypotenuse is 6 meters more than twice the shortest side. So let the shortest side be x. So let the shortest side, which is AB in this case. So let the shortest side AB be equal to x. And the hypotenuse is 6 more than. So hypotenuse will be 6 more than twice the shortest side. So hypotenuse therefore will be 6 plus 2x. And the third side is 2 meters less than the hypotenuse. So the third side will be 2 meters less than the hypotenuse. So the hypotenuse is 6 plus 2x. And the third side is 2 meters less than it. So therefore, this will become 2x plus 4. So this is the third side. This is 2x plus 4. Right? And now, of course, I can use Pythagoras theorem. But again, the important part is framing the different sides. So let me pause for a minute so that you can take a look at it. Okay, so using Pythagoras theorem, let us solve this question now. We have 6 plus 2x the whole square is equal to x square plus 2x plus 4 the whole square. Using a plus b the whole square, I get a square, that's 36, plus 2 times a times b, that's 24x, plus b square is 4x square, that equals x square plus, this is again a plus b the whole square, so it's 4x square plus 16x plus 16, right? So now again, let's see if some terms cancel. Over here, 4x square cancels. Let's group all the terms on one side. So I get x square minus 8x minus 20 is equal to 0. And I can now use factorization technique. So therefore, this therefore becomes x minus 10 times x plus 2 is equal to 0. And therefore x is either equal to 10 or negative 2. Now again, the side of a right angle triangle cannot be negative, which is why we discard x equals negative 2 and we consider x as 10. So the sides are 10. The hypotenuse is 6 plus 2 times 10. So 6 plus 2 times 10 is going to be 26. And the third side is going to be 2 times 10, that's 20. Plus 4, so it is going to be 24 centimeters. So the three sides are 10 centimeters, 24 centimeters and 26 centimeters. So again, I'm going to pause for a minute, let you take a look at the solution and then we solve our final question. Moving on to the next question. Let us consider the following question. The hypotenuse of a right angle triangle is 3 root 5 centimeters. So there is a right angle triangle whose hypotenuse is 3 root 5 centimeters. So let's consider the right angle triangle is ABC, and the hypotenuse is 3 root 5 centimeters. If the smaller side is tripled, now by the way, I haven't allotted any smaller side, so let's assume that AB is the smaller side. So let AB be the smaller side, and that equals x centimeters. And there is a larger side therefore, so let y be the larger side. So let BC be the larger side. Let BC be the larger side and let that be equal to y centimeter. Now let's see what is the condition given. If the smaller side is tripled, so smaller side is tripled means now we are enlarging this particular triangle so that the smaller side now becomes 3x, right? So this becomes 3x, this becomes triangle PQR. There is a 90 here. So if the smaller side is tripled and the largest side is doubled, that means the larger side in this triangle is y. So the larger side here is going to be 2y. Then the new hypotenuse will be 15 centimeters long, right? So these are the two triangles. There are two variables here, x and y. So this is the first triangle and this is then the enlarged triangle. Now we have to find the length of each side. So we have to find the values of x and y. So what I'm going to now do is I am going to frame the Pythagorean equation for both these triangles. So I get x square plus y square is equal to 3 root 5 the whole square, which means x square plus y square is equal to 3 square is 9 and root 5 square is 5. So x square plus y square is equal to 45. This forms the first equation, right? This is my first equation. And let us take the second triangle now. So in the second triangle, I can say 3x the whole square plus 2y the whole square is equal to 15 square, which means 9x square plus 4y square is equal to 225. So this forms my second equation, right? So this is the second equation that I have. And now if I want to find the values of x and y, I should now be eliminating either x or y. Treat this as simultaneous quadratic equations, right? So let us quickly eliminate one of them. Let's eliminate y. So let's multiply this by 4. I get 4x square plus 4y square is equal to 180. And 9x square, that's the second equation. So 9x square plus 4y square is 225. If I now subtract y square vanishes. So 4x square minus 9x square is minus 5x square is negative 45. And therefore x square is equal to 9, which means x is again positive 3. Again, we have to say that we are discarding the negative value of x because side cannot be negative. Therefore, the side of the triangle is 3 centimeters. Now it's possible to find the value of y. Again, simply substituting the value of y will help. Value of x will help. So substitute x equals 3 centimeters in any of the two equations. It's your choice. So I will substitute it in the first equation. So x square is 3 square plus y square is 45. And solving this, you will get y equals positive 6. So one side is 3 and the other side is 6 centimeters. Let's do a quick check. Suppose I triple this side. So 3 centimeter becomes 9 centimeter. And the smaller side is doubled, so it becomes 12 centimeter. I know that 9, 12 and 15 is a very well-known Pythagorean triplet. And similarly, 3 and 6 and 3 root 5 is also a Pythagorean triplet. So the given values of x and y definitely satisfy both the conditions and hence our solution is right. So this is how we solve quadratic equations based on age as well as on geometry, and I'll pause for a minute and we end our today's session over here. Ending today's session here.